Right? Let's continue for calculus application. So this is in the topic of maxima and minima optimization. Okay, so we're gonna apply now in problem solving these differentials in the process of differentiation. Okay, things like that. So we have at least 22 plus differentials, and we're gonna apply that here. And this is not only plain differentiation, we're gonna also apply the basic concepts of geometry, no? Plane geometry, because we're gonna involve also a lot of shapes here, no? Areas and volume as well. Okay? So number one. Okay. So this is to practice ourselves for optimization, maxima, and minima problems. Okay. So number one, find the two non-negative numbers x and y, and for which x squared y is a maximum. So if there is maximum, minimum like that, so this is our identification already that it's gonna be specifically differential calculus topic. See, so it's very clear. So maximum, maximize like that. Okay. So there's a hint and clue what is really our solution. Okay, so number one, this would be an advantage. Okay, okay, so we have question number one, solution. Number one, solution. Okay, so find the two non-negative numbers. So let x and y is our negative numbers, no? And then, okay. Okay, and for which express the maximum. So find the two non-negative numbers x and y. So what's this? Multiplication or addition? Okay, find the two non-negative numbers x and y, and for which x squared y is a maximum. Okay, so this is addition, huh? Okay, find the two non-negative numbers. Okay, find the two non-negative numbers x and y, and for which x squared y is a maximum. So this is addition, not multiplication, right? Your idea also, because here is already multiplication, so the other one will be another mathematical operation, right? So it should not be redundant in each operation to be used, no? So that's the technique also. One operation, one mathematical operation, equation one, another mathematical operation, equation two. But if these are the same, then you will be confused, and there's a hint that we will be wrong. Okay? Because actually, if I am who made this problem, I would like to say, find the sum of two non-negative numbers x and y, and for which x squared y is a maximum. If I am the one who will try to write or to offer this problem, so that it could become clear. Okay, but here it's not clear. So why it's not being clear, Sir Sotero? Because this is to measure our total comprehension. This is an exam. So most of the times, it's not evident. It's not obvious in the phrases, in the sentences. You will think deeply what it means. So that's their objective, okay? You get the point? So that's the objective of the board of examiners, or the one who will make the question. See, find the two non-negative numbers x and y, and for which x squared y is a maximum. There's no idea that this x and y are being added or subtracted, right? Okay. Okay. Okay, so first equation. So, but before anything else, we're gonna introduce the technique of optimization, maxima and minima. The first is to illustrate a diagram. This is number one. Okay, illustrate so that we have an idea. We have a flow to follow. Okay, so illustrate the diagram or let us say sketch. Okay. Number two, we gonna establish our unknowns. Establish our unknowns, no? Let's say let x, let y, like that. Number three, formulate equations. Okay, formulate equations by using algebraic expression. Okay, algebraic equations. Okay, things like that. Or let's say formulate equations or formula by using algebraic equations. Number four, you need to set your first derivative is equals to 0. Okay. Okay, so that you get one variable only. So that you get one variable. Okay. Number five, you're gonna test, okay, your answer, okay, by following the second derivative test. Second derivative test. Because if you say minimum, that is undergoing the relative minimum. So meaning to say your d squared y dx squared or y double prime, okay, is equals to positive or increasing or above 0. Okay, but if it is maximum, relative maximum, so therefore you can obtain a double derivative y double prime negative decreasing, okay, and below 0. Okay, things like that. So your relative maximum will be concave down and your minimum, okay, will be concave up. So this is our identification, maximum. So we need to say we're gonna get our y double prime. Okay, no, y double prime negative. This one, kasi maximum eh. Okay, things like that. So it will give you an idea, you get the correct answer. But if you don't test that, maybe you are getting the correct answer, incorrect answer. But another also of identifying that if you have illogical answer or not subject to reality, for example, a negative length, a negative width, a negative volume, which is impossible also. You don't need to test the second derivative because it's impossible. For example, the length is very small, it's not impossible to happen because of the given like that. So that's also an identification that you don't need to test the second derivative. Okay, but to make sure, test the second derivative. Okay, that is the sure, no? 100% sure in order to prove our answers are correct. Okay, it's just like telling here that we need to get the values of x and y. Okay, values of x and y, the volume of quantities, area, volume, like that, and everything. No, it's always like that. Okay, if you don't need to get the x and y, we get the length, the weight, with the area, with the volume, like that. Okay. So these are the steps. We should remember this, okay? All throughout in all applications of calculus in the optimization and maxima and minima applications of differential calculus. Okay? Any question? Okay, so that's very clear, huh? So this is for sure. This will come up in the board examination. Okay? In general engineering mathematics. Okay. But we don't expect what type of optimization and maxima minima problems as long as it will come out. Okay. Okay. So we have here. So we will say equation 1. In number 1, we don't need to draw and illustrate because this is not emphasizing a geometry thing or a shapes, right? This is just like a simple puzzle, right? No, or let us say hypothetical variables, x and y variables, and manipulating with some concepts of algebra and also calculus, right? Okay, see. Two non-negative. Okay. Non-negative numbers, what does it mean? Positive, of course, non-negative, right? Okay. So we have here x plus y is equal to, okay, unsa man. Find the two negative numbers x plus y and for which x squared is the maximum. So you don't know. Okay. So let's say question mark. Okay. Okay. See, x plus y is equals to question mark. Okay. And for which x squared y is a maximum. So x squared y is a maximum. Okay. Things like that. So since the condition here says that x squared y is a maximum, so this portion here we need to differentiate. Okay, because this is a continuous compound sentence. See, x squared y is a maximum. So this is the time we need to differentiate the x squared y. Here kasi it's not saying we need to differentiate because the x and y are not maximized in the sentence. Okay? Be careful also with the grammar accuracy. See? For which x squared y is a maximum. Okay? So if it follows the sentence in that phrase, then you're gonna maximize or minimize. You're gonna differentiate that condition automatically in calculus problems. Okay? Applications. So you're gonna say in this thing, no? So you're gonna say dx, dy like that, no? Is equal to 0 here, no? Is equal to 0 because this is the rule. You need to equate to 0. The first derivative. This is just like saying first derivative, huh? Okay. Or you can say dy dx, no? This is y prime. If you will say x dx dy, that is x prime. If you will say dy dx is y prime. Okay. Things like that. So we will solve this with in differentiation, the derivative of y with respect to x, if this is the case. Okay? Yeah. I hope we need to understand how it means, because the moment we will reverse it, we could still understand. Okay? Okay? Okay. Now, since we don't have the total of these two negative numbers, okay, so we can assume any total of these two x and y. If the problem will be like this, you need to assume any numbers of x and y the total. Diba? Oh, let's say assume a, no? So we'll say x plus y is equals to 8. Assumption basis of calculations, because it's not being specified in the problem. So don't force your brain cells, that you need to always to have this given, even though there's no given at all. This is headache. We need to force even though that is not given in the problem. If that is not given in the problem, you need to have assumption basis and any basis of calculation. Okay, these are very important in math and science. If there's no specific given, you need to have your assumption basis or the basis of calculation. Basis of calculation are normally relates to the standard formulas, equations, the values of the standard constants, and you're gonna apply that there, things like that, no? Okay, so here we assume that the total or the sum of x and y is a. Okay? Okay, things like that. Okay, so it looks like very small, right? Okay, let's increase this to 100. Okay, 100. So x plus y is equals to 100. Okay. Now I said a while ago that y prime dy dx x squared y. So I need to solve for the y in equation 1. Right? This is equation 1. This is equation 2. No? Okay. So I need to have y is equals to 100 minus x. Then this y will be substituted here. So I will say y prime is equals to x squared times 100 minus x. Y prime, okay, is equals to 100x squared minus x cubed. No? Okay, since you are equating y prime to 0, that this whole expression will be equal to 0. So factor this one, right? So if you factor this one, we have x, then 100x. 100x squared divided by x, di ba? Is equals to 100x. X cubed divided by x is equals to x squared. It's equals to 0. Now, here, you're gonna equate both to 0. So x is equals to 0. And this whole thing, 100x minus x squared is equals to 0. Right? Things like that. Okay. So there's still another x here. Right? So actually, here, there's two methods here, huh? This one, 100x minus x squared. So either you're gonna factor it again by x. See what? 100. 100x divided by 100. 100x, 100, right? X squared divided by x, like that, no? Is equals to 0. And again, equate x to 0. Then 100 minus x is equals to 0. Therefore, minus x equals to negative 100. Cancel the negative sign. X is equals to 100. Okay? So x is equals to 100. Okay, things like that. X is equal to 100 and also x is equal to 0. There are two answers here. That's why you need to test the double derivative. Okay, the double differentiation, no? Or the second derivative. Okay, because there are two answers. Either 0 is maximum or either 100 is maximum. Because in calculus, guys, it doesn't mean the least number is the lesser number is the maxima. There's no such like that. We need to test by patterning that all throughout. Sometimes a little bit bigger, that's minima, sometimes lesser, like that. So we are not sure for that. That's why we need to do the second derivative test, which is y double prime, no? Is equals to 0. Okay, things like that. Okay? Okay, things like. Then here, guys, I told you, as I promised a while ago, this contains two methods. If you say 100x, then we're going to equate directly that to x squared. Cancel, cancel. So x is equals to 100 directly. No need to equate h to 0 there. So there's two methods also. If we learn about algebra, we can use our own autonomy, no? Our flexibility, what methods we will be able to use as long as we understand it. Okay? There's no such specific technique to use. It depends on our convenience and comfortability. Okay, our comfort. Okay, things like that. Alternatives, what I mean. Okay, so if you want this more direct, this one also okay. Okay, now I need to test that because I don't know whether 0 or 100 is the maximum. Okay, you may answer. Okay, things like that. Since I know that y double prime is already this one, I need to have the second derivative of this, no? Which is the y double prime. Derivative of 100x squared, 2 times 100, 200x. 3x cubed, 3x squared, no? Things like that. That's our second derivative. Now, if we substitute 0 here in the value of x, okay, y double prime is equal to 200 times 0 minus 3 times 0 raised to the power 2. So 0 to the power 2, 0, 0 to 3, 0. Okay, 0 times 100, 0. So y double prime is equal to 0. So what's that? When y is equals to 0, y double prime is equal to 0, and this is just saying dy dx, d squared y over dx squared is equals to 0, meaning to say it's saman. Okay, it's positive or going up. So if it's positive or going up, what's this relative maxima or relative minimum or minima? This is minima. Okay? So meaning to say, this is not the answer because maximum. So 0 is not your answer. How about 100? Substitute to the second derivative. Okay. So if we get a negative answer of our second derivative, and that is the maxima. That is the answer. So that's why you need to test. Okay? Okay, so let's substitute that to the double derivative or the second derivative. Kani siya, y double prime is equal to 200x minus 3x squared. So i-substitute ang 100 because you have two values of x which is 0 and 100. Okay, so y double prime is equal to 200 times 100, 3, 100 raised to the power 2. 100 raised to the power 2. So that is taking, what ka 0, no? 10,000. So 200, 5. Okay, 2, upat ka 0. 1, 2, 3, 4. So 20,000, no? Right? See, 100 times 200. See? 100. Timurang kopya ng pila ka 0. Diba? Pila ka 0. 1, 2, 3, 4. Din kopya ha. 20,000 nga. Okay. Then, 100 kaduha on. 0, upat, no? 10,000. 10,000 times 3. 0, 0, 0, 0. Okay, 30,000. So 20,000 minus 30,000 is equals to negative 10,000. So your double derivative or second derivative is a negative value. So when your second derivative is a negative value, that is obtaining a relative maxima. This is maxima, maximum. So meaning to say your answer is 100. Okay, 100 ang imong x. X is 100. Okay, how about your y, sir? Y is equals to 100 minus x. So y is equals to 0. So 100 and 0. Your answer. X is 100 and y is equals to 0. Okay? Because we are assuming a number which is also 100. So if we change this 150, 200, 3,000, 80 or any values of this, it will also change not to become 0. Okay, this one. Right? Kataon man siya nga, if I subtract 100 to x, it will become 0. Okay? Things like that. Yes, sir, you said non-negative number. Okay? Yes, this is non-negative. 0. Okay? Things like that. So it follows also. That's our number 1. Okay? Our equation number 2, our problem number 2. Okay, things like that. Okay, our problem number 2, what's this all about, guys? So this is a wire 16 feet long has to be formed into a rectangle. So your wire must be formed into a rectangle. Okay? So this is a little bit of critical thinking or analysis. What dimension should have to maximize the area? Okay, so see, 16 feet long. Then you need to make that as a rectangle. So if that is the case, you need to fold this 16 feet so that it will become a rectangle. This 16 feet, you need to fold that, okay, so that it will become a 16 feet. Okay, so in that case, let's say 16 feet, this one, 16 feet. So you need to produce the height like that. Okay, 2 height and 1 width also here. Height by this 16 feet alone. Okay, so how can you do that if that is the case? So automatically, when you add this dimension, the 16 feet here, by common sense, it will now become the perimeter. This kind of problem is not direct because you have to think. Because it's not mentioned here the word perimeter. It's not obvious kasi. See? A wire 16 feet, it looks like this is a length lang siya eh. But the way how you think deeply, you need to form a rectangle. So meaning to say, you need to bend, you need to fold so that this 16 feet will become a rectangle. So we need to say this 16 feet will be adjusted, no? Things like that. Okay, so what dimension should have to maximize the area? So area is being maximized. Okay, so what is the area of a rectangle? For example, this is the area. Okay, so this is the area. Okay, so this is let us say okay, so this is y, and x. Okay, what is the area of your rectangle? Okay, saman, diba x times y? Okay, things like that. Okay, x times y. See, x length times width. Because rectangle and square have the same formula. Tama ba? X and y. But it happens that the dimensions of square are equal. But in the rectangle, it's not equal. Only the two sides, the two opposite sides, okay, are equal. See? 1, 2. Okay, things like that. But this is x times y. This is equation 1. Okay. Equation 2, so perimeter. Okay, because you are adjusting your 16 feet wire to become the perimeter because your purpose is to make a rectangle. Okay, so what is the formula of a perimeter by elementary math, grade 5 or grade 4? Okay, so that is 2y, y plus y, okay, plus x plus x, 2x. Then factor that one is gonna be 2 times y plus x. Okay, equation 2. Okay? Tama ba? Okay, but you have the perimeter which is 16. Substitute that here. 16 is equals to 2y plus x. Perform the indicated operation, distribution, multiplication, distribution. Y times 2, 2y. X times 2, 2x is equals to 16. This will not become negative, because this is commutative property. When you try to reverse, it's just the same. Okay, things like that. So we have here x and y. You need to maximize your area. dA, okay, dy dx, no? So you say dA because it's already area. Derivative of area with respect to x. Parang ganon, no? Kaloka. Okay? So things like that. So let's say I'm gonna compute for y here. So I will say 2y is equals to 16 minus 2x. Then 2y, or let's say y, 16 minus 2x divided by 2. See? So that it will be cancelled, no? Divided by 2. So y is equals to 16 minus 2x divided by 2. So therefore, y is equals to 16 divided by 2, 8. 2 divided by 2, 1. X. So y is equals to 8 minus x. So substitute this 8 minus x here in your area. Okay, so it's it. Okay, that's y. So x times y carry 8 minus x. So 8 minus x, multiply this 8x distribution again, no? 8 times x, 8x minus x times x squared. Since this is equals to 0, because we need to equate the 0, our first derivative of the area, no? And then here, 8x minus x squared is equals to 0. Then factor out in terms of the variable. Okay, so 8x. Gano'n kasi yan, 8x divided by x, 8. X squared divided by x, x. Is equals to 0. Therefore, equate both sides. X equals to 0. 8 minus x equals to 0. Therefore, x is equals to negative 8. Tama ba? Okay. So, x, yes. Cancel. X is equals to 8. So, we have two answers again. X is equals to 8 and x is equals to 0. Okay, now, we need to test the second derivative so that we can determine what dimensions you have to maximize. So, since 0, it's nothing, right? So, obviously, 8 is the correct answer. You don't have to test. but let's just test in the benefit of a doubt. Okay, things like that. Okay, the second derivative of this na. Okay, this one. Because this is the first derivative. Tama ba? Tama ba? Oy, nag-algebra pa ko. Sorry. sorry. Okay. Differentiation. No, sorry. It's not algebra pala. Sorry. Okay. So, since I distribute this one, 8x minus x percent, I am saying the differentiation. No? Nabuhan ng utok na ko lang. Kuha pa ko nag-algebra. Okay. So, this is not 0 and 8 because we are in calculus. we are not in algebra kasi. Oh, sorry po. Okay? Things like that. Oh. Naanad ko sa algebra. Okay, thanks. Okay, so 8x minus x, let's differentiate this pa. We be careful, ha? Because this is the usual mistake. Because we are very, in our solving, we forgot that we are dealing with calculus. Okay, so this is a problem, right? So at least you need to be focused, no? Because in this kind of problem, guys, this cannot be solved by algebra. This is exclusive only to calculus. Why? Because there is a word maximize. So no other math can solve it directly. It's not integral, it's not differential equation, it's not geometry, exclusive differential calculus. If we see maximize and minima. Unlike other problem solving that you have any options to use, you can solve by algebra, you can use sometimes also geometry, sometimes integral, sometimes calculus. But in this special topic, no. Okay, that's the problem. The moment we will be an error here, we don't differentiate, then we cannot determine the correct answer. But again, other problems can be solved in any topics in math, except for this, because this is very specialized kasi, see, maximize, minimize, like that, okay? Ay, nako po. So 8x minus x squared is equals to 0. So funny, right? So first derivative of 8x is 8, then the derivative of x squared 2x is equals to 0. Therefore 8 is equals to 2x, therefore x is equals to 4. No? Because x 8 divided by 2 is 4 man siya. Okay, so your value of x is 4. Is this correct? Okay, now, second derivative test. Actually, we don't need to test because we don't have other value of x. Okay? Get the point? Okay, we don't have other value of x, so no need to test. Okay, since we have y is equals to 8 minus x, so therefore y is equals to 8 minus 4 is 4. Okay, so your dimension will be 4 and 4. Okay, in which if you multiply these two, it will become 16. The area. See, 4 times 4, 16. So perfect. Okay, no need to test, we need to test only if we have two values of x. We have two values of y, like that. The moment you have only one value, you don't need to test because you are wasting your time. Get the point? Things like that. So that's it. Any questions so far? Okay. So what triggers here the increasing difficulty? The moment we will encounter different types of shapes. For example, the rhombus, the parallelogram, the sphere, the right circular cone, the pyramid, like that. Since if you don't know the formula of those shapes, then even though you are very good in differentiation, you cannot still get the correct answer. Okay. That's why the prerequisite of calculus, is analytic geometry, and algebra, and trigonometry also, because it can be used in calculus. That's why that's the prerequisites. Okay, there's a purpose. You cannot take calculus if you will not pass this lower maths. Okay, this is an example. Okay, things like that. And especially in differentiation, it will use a lot of trigonometric functions there. Okay, see? If I will say the derivative of arcsecant x. Oh, so this is trigonometric functions, right? In the topic of trigonometry, but we blend that in differential calculus or either in the integral calculus. So that's why prerequisites, okay? So what is the derivative of secant negative x? Parang ganun, okay? Okay, so how this? So this is just like saying, okay, 1 over the square root of x squared minus 1. This is the derivative of arcsecant x. Actually, there's memorization. You got the point? Oo. So dapat strong. We have a strong memory retention. Okay? Things like that. This one. Pabor diri ang paspas of memory retention sa differential calculus formulas and integral calculus formulas unless the exam is open book, but usually not open books. Okay, that's the point, or not open notes. Okay. I just don't know the mode of at the present examination in calculus or any math nowadays, no? Okay, maybe we have also special open notes, special open books. But before, no. Okay, in the 90s to 2000, no. No open. But we are allowed to open our chemical engineer's handbook, the very thick Peary's chemical engineer handbook, because even though you will still open that, you cannot still get the correct answer perfectly because so many info inside that chemical engineer's handbook. Okay, the moment you will not know the respective chapter where to go, problem also. Okay, that's what we did in our bachelor's degree at the time. We have index label from A to Z, so that if the problem is like this, we can go directly. Me, before I label it with orange, red, because I'm so very creative. Okay, in terms, I want a colorful life. I want bright colors. I don't like white and black. I don't want black, white, and gray colors. I'm into bright colors. Okay, sorry to say this. Okay, that's the reality. Okay, okay, things like that. Okay, so red, orange, yellow. So what I did, I followed the hierarchy of the rainbow. Okay, the Roy-Bev, the arrangement of the visible rays in the electromagnetic spectrum. Right? So, because I understand already this, including the wavelength like that, no? Okay. Okay. So, red, orange, yellow, green, blue, indigo, and violet. Since I don't know perfectly what is an indigo, I will go directly to violet. So, I have 6 colors in my handbook, and I will put that there so that, for example, the topic is like this, and I can go directly there. Especially the physical and chemical properties of all chemicals in the planet Earth. It's in the chemical engineer's handbook from A to Z. You cannot memorize that, okay, even though you are summa cum laude. Okay, really, you need to bring that chemical engineer's handbook and go there because billions of chemicals will be there, arranged from A to Z. And these chemical and physical properties, so many also. You get the point? Viscosity, surface tension, like that. Density, specific gravity, volume, pressure, temperature, volumetric flow rate, mass flow rate, and then there's a lot of rows, and column, like that. Okay. Okay, heat capacity, specific heat capacity, ganun. Thermal conductivity, things like that. Inductance, impedance, like that. No, capacitance of each element and chemical, and it's also the electromotive force and its potential or the voltage of those elements and chemicals, because chemicals and elements conduct most of the times electricity. Okay, that's why we have topic of electrochemistry, combining chemical reactions and chemicals to produce electricity. Okay, and one of the examples, the basic galvanic cell, the battery. Okay, the zinc part, the copper part, like that, no? The cathode, these are chemicals. Okay. Okay, without chemicals, then there's no cell phone. It will not conduct electricity because elements and metals are conductive to electricity. Okay? Except na lang siguro sa mga metalloid, other non-metals. Right? Non-metals, of course. Okay? Ay, Diyos ko, nag-chemistry pa rin. Okay, mathematics. Okay, thank you so much. Okay, for that application. I cannot stop myself from incorporating talaga science. Okay. Thank you so much. Bye-bye. God bless everybody. See you later.